Hi, welcome to my talk. My name is Mei. I work at Yahoo Japan. Today I'm going to talk about location prediction method using a knowledge base. This is the outline of my talk. Location prediction is a task to predict relevant locations from news article text. For this article, if we decide to predict at prefecture level, then the expected output is Tokyo Prefecture. If we decide to predict at municipality level, then the expected output is Shibuya. The most natural method of choice for location prediction might be machine learning based method. However, there are some disadvantages in using ML based methods. Preparing training dataset is a pain. Interpretation of the results is often hard. In addition, municipal mergers are frequent in Japan, so performance can degrade over time if you do not maintain the ML models. We propose location prediction method using knowledge base. It requires no training at all, allows for easy interpretation, and by using the fresh knowledge base, we have an updated knowledge about the world. Before we go on to the details, let me briefly describe what knowledge base is. In our web search service, when users search for Nobody Knows, a Japanese movie, entity panels are shown on the search result page. An in-house KB is used as a backend to generate this panel. The part of KB that is used to show the entity panel might look like this. The leftmost rectangular node represents the movie Nobody Knows, and it is connected to director Hirokazu Koreeda and actor Yuya Yagira. In general, KB consists of information about entities in a structured, machine-readable graph format. Entities correspond to persons, places, companies, etc. in the real world. In this talk, we use part of the KB that is related to locations. For example, the leftmost node represents Tokyo Prefecture, and it contains Shibuya, and Shibuya contains the famous Shibuya Crossing. Now we will describe our proposed method. Our proposed method consists of 4 steps: creating gazetteer, identifying phrases, entity linking, and scoring plus propagation. We will explain each step in more detail. In the first step, we follow edges that correspond to names in the KB and create a dictionary or gazetteer that consists of names of places and entity ID. Follow this red shadowed edge to add Shibuya Crossing corresponds to ID 300, and so on. In the second step, we select phrases that are useful for location prediction from news article text using the gazetteer. We also used named entity recognition tool to differentiate between person names and place names, and morphological analysis when looking for partial matches in text and gazetteer entries. In the third step, entity linking, we used gazetteer to resolve each phrase to entity ID. In this presentation, rounded squares represent phrases, and ordinary rectangles represent entities contained in the KB. When there are multiple possibilities, we take other phrases in the article in consideration. We show 2 example cases. Case 1. When there are multiple candidates for a phrase Nagano, such as Nagano Prefecture, Nagano City, and Nagano Station. Here we assume the other phrase, Nagano Station, is already linked to entity ID 403. In this case, we choose the entity that the other phrase is already linked to. Case 2. When there are multiple candidates for a phrase, Shiraito Falls, and one is located in Fujinomiya City, and the other is located in Karuizawa Town. Here we assume the other phrase Karuizawa is already linked to entity ID 811. In this case, there is a candidate entity that is located in the same area as ID 811. Therefore, we choose the entity ID 617 that is located in the same region as ID 811. In the fourth step, scoring and score propagation, we first score each phrase. We score such that longer phrases and phrases that appear earlier in the text results in higher scores. This is because the longer phrases are less likely to be linked to wrong entities in the entity linking step, and phrases that appear earlier in the text are more important in terms of location prediction. And we propagate the scores to entities and eventually to higher level administrative regions such as cities and prefectures, like this. Finally, if the score of the prefecture is larger than the threshold, we return that prefecture as relevant prefectures for the article. We go on to how we evaluated our solution. The dataset for evaluation consists of 1,711 news articles. We asked professional annotators to annotate each article with a set of relevant prefectures. There are 47 prefectures in Japan. Here, we allow multiple prefectures to be labeled on a single article. As a result, each article had 1.29 labels on average, but 28.4% of the articles were annotated to have no relevant prefectures. For these articles, the location prediction method should return an empty set. For comparison, we created two baselines. The first baseline is based on Gazetteer. We create Gazetteer of cities and prefectures from official data without using the KB. We simply perform named entity recognition on the first 20% of the text, and if there is a partial match with entries in the Gazetteer, we return corresponding prefectures as relevant. The differences between this baseline and the proposed method are that there are no landmarks in the Gazetteer and only cities, words, and prefectures, and there are no use of hierarchical relations between places. The second baseline is machine learning based. We solve location prediction at prefecture level as multi-level classification problem. We used the fastText library for this baseline. The differences with the proposed method is its ability to learn location indicative words from the dataset. This is an advantage, and the training dataset is required. This is a disadvantage. We used part of the evaluation dataset for training and evaluated this method using nested fourfold cross-validation. We compared the proposed method with the baselines. Our proposed method performs the best. The Gazetteer baseline suffers from low precision. One reason for this is because it cannot differentiate cities or villages with the same name. The ML baseline suffers from low recall. This is because the training dataset size was not large enough to learn all the names of cities and prefectures in Japan. To wrap things up, we presented a simple KB-based method for location prediction. The advantages of our method are as follows. Since our method requires no dataset for training, changing granularity of location prediction, such as switching from prefecture level to city level, is easy. Our method is easy for humans to interpret. For example, more phrases that describe a specific prefecture results in higher scores. Given a fresh KB, the method maintains performance even when municipal mergers take place by updating the Gazetteer. Thank you.